Given question, draw shear force diagram and bending moment diagram. Find the location of point of contra flexure or point of inflexion.
In this question, beam carrying point load, uniformly distributed load and uniformly varying load. To draw the shear force diagram as well as bending moment diagram, first step is to draw the free body diagram. Now if we observe, the beam is supported at 2 points A and D. So we have to show the reactions in upward direction at point A and at point D. So we will show these reactions as a RA in upward direction, and at point D we will show this reaction as a RD. Now we have to show this point load at point B as a 30 kilonewton. Now if we move to the span CD, then there is uniformly distributed load. Now this uniformly distributed load is 10 kilonewton for 1 meter, and it is distributed over the span of 4 meters. So for 4 meter, how much load is there? So it is equal to 40 kilonewton. So we have to show here. So what is this total load? Total load is equal to 10 multiplied by 4, 40 kilonewton, and point of application of the load is the middle point of the span. So we have to show this. So we will first select the center of the span CD. So here is the center point. So this is the point of application of this total load 40 kilonewton. Now we will move to the next. Now if we observe the span DE, then there is uniformly varying load. So for this uniformly varying load, maximum load is given 15 kilonewton per meter. Now how to find out the total load? So for uniformly varying load, total load is equal to area of triangle. Area of triangle. So if we observe how to calculate the area of triangle, that is equal to half multiplied by base multiplied by height. Now we will consider here the base is equal to this length DE or span DE, and that is equal to 3 meter, and height is equal to this load mentioned 15 kilonewton per meter. So we will take height is equal to 15. So we have to consider this maximum load. So if we calculate this, then we will get 45 by 2, that is equal to 22.5. So this is the total load. Now we have to find out point of application of this load. So for uniformly varying load, point D is the point of maximum load. So I will draw here separately. So this point D is the maximum load, because here this maximum load 50 kilonewton per meter is given, and the point E is minimum or zero load. So here the zero load is mentioned. So here is the point of application of this load 22.5. So from this maximum load we have to take, it is equal to 1 by 3 multiplied by total span. So this 1 by 3 multiplied by 3, and the remaining, or from this other point, that is from the E or minimum load, we have to take 2 by 3 multiplied by this total length. So we will take here 2 by 3 multiplied by 3. So if we observe from this point D, it is at the length 1 meter, and from this point E it is 2 meter. So we will select here one point. So this point is from point D is equal to 1 meter, and from point E is equal to 2 meter, and we will show this total load. So this is the point of application of load, and it is 22.5 kilonewton. Now we will move to the point E. At point E, 10 kilonewton is the inclined force that is mentioned. So we will resolve this into two components. One is vertical component and other is horizontal component. So when we resolve, how to show it's a component? So the component nearby to angle 60 degree is known as cos 60. So we will say that this value is 10 cos 60 and for the vertical component 10 sin 60. From the free body diagram, we will find out the unknown forces. We will consider the system is in equilibrium. So when the system is in equilibrium, we can say that summation of all vertical forces is equal to 0, summation of all horizontal forces is equal to 0, and the summation of moment of all the forces about any point is equal to 0. So we will show all these three equations. So first will be summation of all vertical forces is equal to 0. If we observe this 30 kilonewton, 40 kilonewton, 22.5 and 10 sin 60 are in vertically downward direction, and this RA and RD are in vertically upward direction. So we can say that RA plus RD is equal to 30 plus 40 plus 22.5 plus 10 sin 60. So it is equal to 101.16. So we can say that this is the equation number 1. Now we will move to the next. Summation of all horizontal forces is equal to 0. If we observe this diagram, here is the horizontal force. So to balance this at point A, we have to show the reaction at point A, that is known as HA, because this is the horizontal component at point A. So to balance this, we have to show that from this diagram, we will say summation of all horizontal forces is equal to 0. But these two components are opposite in direction. So we can say that HA minus 10 cos 60 is equal to 0. Therefore, HA is equal to 5 kilonewton. So value of HA is equal to 5 kilonewton. Now we will move to the next. So this will be our equation number 2. Now next is summation of moment of all the forces about any point. So we will consider here about point A is equal to 0. So how to show this? So for that we have to take moment of all the forces about this point A. So how to take moment? Force multiplied by distance. So if we observe this 30 kilonewton, if I move the compass about point A, then it is in clockwise direction. So for this clockwise direction, we will take positive sign, and for anti-clockwise direction, we will take negative sign. So 30 multiplied by 2 plus same 40 multiplied by, so distance from this 40 is this 2 plus 2 plus 2, that is 6. Then this RD, so RD is in anti-clockwise direction about point A. So minus RD multiplied by this distance, so it is 8 plus 22.5 multiplied by this distance, so it is in clockwise direction, so it is, this total distance is 9. Then 10 sin 60 multiplied by this distance, that is 11, is equal to 0. Now what about this 10 cos 60? So if we observe, if we extend the line of action of force, then it is passing through A. That means distance is equal to 0. So for this component, moment about A is also equal to 0. So when we solve this, then we will get the unknown term RD. So it's a value 74.71 kilonewton. Now we get the equation number 1 in terms of RA and RD. So when we put the value of RD, then we will get the value of RA 26.44 kilonewton. To calculate shear force, we have to take the summation of all the forces either on the left hand side or on the right hand side. In this question, we will take the summation of all the forces on left hand side of the selected point. We have to first mention these sign conventions. Now if we observe the left hand side of this section, that is the line I have shown with red marker, then when the forces are in upward direction on left hand side, we have to take positive sign, and the direction of forces in downward direction, then we have to consider the negative sign. So first we will consider this section AB. Now for this section AB, I will consider any section that is the vertical line. Now we will take the summation of forces on the left hand side. So on left hand side there is force RA which is in upward direction. So we will say that shear force in between this section AB is equal to plus 26.44 kilonewton. Now we will move to the next section. So we will consider the next section BC. Now I will consider the section in between BC. Now again we will apply the same rule, summation of forces which are on the left hand side. Now there is the force which is in upward direction. So we will take positive sign, that is plus 26.44, and the force which is in downward direction we will use minus 30. So we have to calculate this. Now we will move to the section CD. Now if we observe in between this section CD at point D, there are two types of forces. So one type is the uniformly distributed load. So it is up to the point D. And second is this point load, that is the reaction at point D which is in upward direction. So how to calculate the shear force for such a section? Now we will consider the 2 points. One point is just at the left side of this point D, and the second point is just at the right side of the point D. So we have to calculate shear force just left at point D and the second shear force just at right side of the point D. Now we will consider the section at the left side of the point D. So again we will apply the same rule. We will take the summation of forces on left hand side. So on left hand side there is upward direction. So here we will take plus 26.44, then second minus 30, and next is minus 40. We have to calculate this. Now we will move to the just right side. So for the just right side, I will consider the next section. I will show here with red marker. Now again we will apply the same rule. So we will use this sign convention. So here with vertical direction we will use plus 26.44, then minus 30, minus 40, and next there is reaction which is in upward direction. So here plus 74.71. So these two we have to calculate. Now we will move to the next. So next section is section DE. Now if we observe at point E, there is the point load. So again we will consider the 2 points which is just at the left hand side and second just at the right hand side. So first we will calculate just left hand side of the E. So I will show here the section line. So again we will calculate here. So with this sign convention I will take plus 26.44 minus 30 minus 40 plus 74.71, and then here 22.5, so which is in downward direction. So we will use minus 22.5. Now we will move to the just right hand side of the E. So here if I take here the section, then we have to consider this 10 sin 60. So again we will calculate this. So we will write as it is, that is plus 26.44 minus 30 minus 40 plus 74.71 minus 22.5. Now this 10 sin 60 is in downward direction. So again minus 10 sin 60. So we have to calculate all these. To draw the shear force diagram, we have to first draw the baseline. We have to plot the positive numbers in upward direction and negative numbers in downward direction. There are some rules we have to follow. So whenever in any section there is point load, then we have to show the shear force with constant line. When there is uniformly distributed load, then we have to show shear force with linear line, that is in this way inclined line. Then for uniformly varying load. If the load is increasing, then we have to show the convex shape parabola. So this shape is here, I will show here. This is the parabolic shape. So in this way we have to show the parabolic shape if the load is increasing. And if the load is decreasing, that means in this diagram the load is decreasing from this point D to the point E. Then we have to show the concave shape. So here is the concave shape. So this shape we have to show the shear force. Now we will move for shear force in between section AB. So in between the section AB there is the point load. So for point load we have to show the constant line. So magnitude is plus 26.44. So for the positive sign we will show here 26.44 and we will show this with constant line. Now we will move to the section BC. So for section BC it is minus 3.56. So for minus sign we will show in the downward direction. So it is 3.56. So again we will show with constant line. Now we will move to the next CD. So if we observe, we have to take the point where just left hand side of D. So it is minus 43.56. So if we observe, we have to plot here minus 43. Minus 43.56. So because of negative sign we have to plot this point in the downward direction and just right at D. So it is plus 31.15. So we have to plot here plus 31, that is above this 26. So here is 31.15. Now these 2 points are just left hand side and right hand side. So we have to plot these 2 numbers on the same line. So this is important point because these 2 points are nearer to the point D. Then we will move to the section DE. So just left at E. So just left at E it is 8.65. So it is having positive sign. So I will mention here 8.65 and next one is 0. So on the same line we have to plot this 8.65 and 0. Now we have to complete this diagram. So if we observe for section CD it is uniformly distributed load. So how to connect this? So we have to connect the point from C to the point which is just left hand side. So if we observe at left hand side value is minus 43.56. So we have to connect these 2 points. So we will draw here linear line because of the uniformly distributed load. Then we will move or we will connect these 2 points because these are on the same point. So I will connect this. Now if we move to the section DE, so in between this D and E there is uniformly varying load and which is decreasing. So we have to show concave shape parabola. So I will show here. So we have to connect the next point which is at the left hand side of the point E because this is the nearer to this point D. So after D we have to take this point. So it is plus 8.65. So I will connect these 2 points with parabolic shape. And then this 8.65 to 0. And we will complete this. To calculate bending moment, we have to take the summation of moment of all the forces either on the left hand side or on the right hand side. In this question, we will take the summation of moment of forces which are on the left hand side of the selected point. Now if we observe the sign convention on the left hand side of this section, if the moment is having clockwise direction, we have to consider the positive sign, and if the direction of moment is in anti-clockwise direction, then we have to consider the negative sign. So we will first consider the point A. Now if we observe on left hand side of the point A, there is no any force, and if we consider the force at the point A, that is RA, then the distance of this force from point A is equal to 0. So bending moment at point A is equal to 0. Now we will move to the point B. Now for this point B, on left hand side there is RA. So if I move the compass about point B in the direction of RA, then it is clockwise direction. So we will consider the positive sign. So with positive sign, 26.44 multiplied by distance in between AB, that is 2. Now bending moment at point C. Now if we observe on left hand side, there are two forces. So one force is in clockwise direction, so it is plus 26.44 multiplied by distance in between AC, that is 4. Then this force, if I move the compass about C, then it is in anti-clockwise direction, so we have to use negative sign. So minus 30 multiplied by this distance is 2. Now bending moment at point D. So again we will apply the same rule. So this force, if I move the compass, then it is in clockwise direction. So plus 26.44 multiplied by the distance in between 8, that is equal to 8. Then minus 30 multiplied by distance in between BD, that is equal to 6. Then next is 40. So it is in anti-clockwise. So minus 40 multiplied by distance in between 40 and this point D is 2. Now we will move to calculate bending moment at point E. So again we will show here, if I move the compass, then this force is having clockwise direction. So plus 26.44 multiplied by the total distance 11. Then for this 30 minus 30 multiplied by the distance, that is 4 plus 2, 6, 8, 9, that is 9. Then 40. So it is again minus 40 multiplied by the distance. So this distance is 2 plus 3, that is 5. Then RD. So RD is 74.71. If I move the compass about E, then it is in clockwise direction. So we will use plus 74.71 multiplied by the distance in between this D and E, that is 3. Then next is 22. So it is minus 22.5 multiplied by 2. To draw the bending moment diagram, we have to first draw the baseline. Now we will plot the different values. So at point A, value is 0. We have to plot the positive values in upward direction and negative values in downward direction. So point at B, it is plus 52.8. At C, it is plus 45.76. At D, it is minus 48.48. And E, it is 0. So we will plot all these points. Now if we observe in between A and B, there is point load. So how to connect this? We have to connect with the linear line. So I will connect from 0 to 52.8 with linear line. Now in between BC, there is also point load. So again we have to follow the linear line. Now for this span CD, it is uniformly distributed load. So for the uniformly distributed load, we have to show the parabolic curve. So we have to connect this span, that is the point C and point D, with parabolic curve. And then D to E. So it is uniformly varying load. So we have to show with cubic curve. So we have to connect this point D to point E with cubic curve. So this is the bending moment diagram. Now if we observe, bending moment changes its sign from positive to negative at this point P. So this point P is known as point of contra flexure. So I will extend this point in the diagram. So I will extend this with vertical line. Now this is the point P. Now how to find out the location of this point P? So again we will show here this free body diagram from this point A to point P, and we will find out the exact location of the point P, because if we observe the bending moment diagram, then the bending moment at point P is equal to 0. We will select the section from this point A up to this point P. So here is the reaction at point A, 26.44. Then this force is 30 kilonewton at point B, and from C to P there is uniformly distributed load. It is equal to 10 kilonewton per meter. Now we have to find out the distance in between C to P. So we will consider this distance as a x. So next step is to draw the free body diagram. So how to calculate the total load, because it is uniformly distributed load 10 kilonewton per meter over the span of x meter. So for 1 meter load is equal to 10 kilonewton, and for span of x meter we have to calculate the load. So for this value we have to take the cross multiplication. So it is equal to 10x. And where is the point of application of this load? Because it is uniformly distributed load, we have to select the middle point for the span CP. So for this span CP, we will take the x by 2 distance on both the sides, and load is equal to 10x. And the other load 30 kilonewton, and then it is 26.44 kilonewton we have to show as it is. Now how to find out distance x? So if we observe this diagram, then we know that bending moment at point P is equal to 0. So when we consider the summation of all the forces about point P, then we have to show it is equal to 0. So we will take the summation of all the forces. So some forces are in clockwise direction and some moments are in anti-clockwise direction. So for clockwise direction take positive sign, and for the anti-clockwise direction take negative sign. Now first force is 26.44. So if I move the compass about point P, then it is in clockwise direction. So we will take plus 26.44 multiplied by the distance in between AP. So it is 4 plus x. So we will take inside the bracket 4 plus x. Next is 30. So if I move the compass about point P, then it is in anti-clockwise direction. So minus 30 multiplied by the distance. So it is 2 plus x. So we will take here inside the bracket 2 plus x. Next is 10x. So it is also in anti-clockwise direction, and the distance in between these two is x by 2. So minus 10x into x by 2 is equal to 0. Now we will simplify this. So we will multiply inside the bracket. So second step is 105.76 plus 26.44x minus 60 minus 30x minus 5x square is equal to 0. When we simplify this, then we will get minus 5x square plus 3.56x plus 45.76 is equal to 0. So we can take minus sign common and we will transfer to the right hand side. And when we solve this equation, then we will get the value of x is equal to 2.69 meters. So we can say that the distance in between C and P. So here is the point C. So distance in between C and P is 2.69 meters.